Good afternoon, everybody. My name is Logan Lohr. I'm the project manager for G.A.L.S. I'm here to present to you today the progress we've made on the Eastgate development project. So I am the structural engineer for G.A.L.S, and with me today is Roberto Alanis and Abraham Steinbeck, our transportation engineers, as well as Ryan Gibbons, our water resources engineer. So, like I said, for structures, I'm in charge of that, and so to recap, I have been tasked with the design of a commercial building that is at least 16,000 square feet, a senior living facility that is at least 20,000 square feet, and then I've also been asked to provide a covered outdoor space of at least 2,000 square feet. So for the commercial building, we have selected a masonry building with steel joists. All these walls will be load bearing, and each unit here is just under 2,700 square feet, and so for a total of 6 units, that gives us a square footage over the 16,000 required. And so this is a single-story building, and so we used the AC 716 loads, and as well as the ACE hazard tool for the snow loads and rain loads and wind loads. And so based on that, we plugged that into a RISA floor, and RISA floor designed the walls with 10-inch masonry units with rebar reinforcing spaced at 16 inches for number 5 rebar. And then for the joists, we selected a 28 LH10. There's a total of 13 joists per unit, and they're spaced at 4 feet each. And then in the future, we will be designing this building in RISA 3D for the lateral loads. And so we're going to make use of shear walls to kind of resist those lateral loads in this building. For the senior living building, we selected a 2-story steel structure. The second story is cantilevered slightly to create the covered outdoor space the client requested. And so because of the variability of this building and different span lengths, the member sizes vary based on the applied loads. For the second floor, we're using the snow load that controls, and for the first floor, we're using 100 PSF for the live load. And so for the RISA results, we got very structured beam sizes of W10 by 12 to a W24 by 55. And then for the lateral loading, we're going to go ahead and assume that in RISA 3D that we're using a pin-pin connection, and then we use steel braces to resist those lateral loads, as opposed to the shear wall in the previous building. So for future work, I'm going to model, like I said, I'm going to model both these buildings in RISA 3D. We're going to also focus on the connection design for each of the members, and then as well as footing design and slab design. We're going to go ahead and either use like a 6-inch concrete slab for the senior living building, and then a steel deck that can span the 4-foot joist spacing for the commercial building. And then once all that's designed, we have quantities and sizes of every member used. We're going to go ahead and compile a final cost estimate using RS means. I'm going to go ahead and pass it off to Roberto now, who's in charge of the northern half of our transportation.
Thank you. Cool. So I'm in charge of the northern portion of the transportation of our Eastgate development project. Just a quick overview. I was tasked with connecting Still Havey Road and Sturdy Road while redesigning/designing, analyzing the current or newly developed intersections. I was also tasked with developing entrances and I guess connections or access to the new building developments, along with parking lots for each of these new buildings, and additionally tasked with pedestrian access along this new development. Here's a couple of my assumptions. I assumed it was going to be a collector road, as there is just a lot of traffic flowing through both Sturdy and Still Havey. I designed for a WB50 with, and each lane would be 12-foot wide lanes. I chose to go with a 2-foot vertical grade and a minimum pavement width between each end of the furthest lanes of 36 feet, and I designed for a design speed of 35 miles per hour. This is my first intersection. This is the intersection at 30 and Chapel Drive. I went with a signalized intersection here with each, I know you can't see it, that is my apologies. Each corner has a radius of 30 feet. And I went with a signalized intersection because I felt like it would allow for a smoother flow of traffic in and out of the intersection. The second intersection, now more clearly labeled, are 30 feet radius on each corner. This is the intersection at Stillhaven Road and Boilermaker Court. Boilermaker Court is over here on the right, and I decided to connect the two with another signalized intersection. The only new addition, this one is mainly the same as it currently is. The only new addition would be the new road development that connects the two existing roads. This is the design of the parking lots. I decided with two separate parking lots as I felt it would allow for easier access and as opposed to my previous design, people going to the senior living building would not have to travel through all of the traffic. The parking lot on the left, or your right, is, am I right? Your left, my right. The parking lot on your right, your left, is the parking lot for the retail center, and the parking lot on your right is the senior living parking lot. My apologies. Each parking space is not extended. It's a 10 by 12 parking space with the two van parking spots being 12 by 20, 10 by 20 and 12 by 20. The retail center has 4 handicap spots with 2 of them being van accessible, and the senior living has 2 handicap spots with both of them being van accessible. This is the typical section for my alignment. I went with clearly 2 lanes on each section. Grade is 2% downward. Then I have a 2-foot buffer zone, grass buffer zone, and a ditch at 3-to-1 slope with the base at 6 feet. And then on the furthest right end, your right end is a 4-foot sidewalk. Yeah, for the future, I plan on refining my work and adjusting as necessary. Next, I'm going to give this off to Abe, transportation of the south.
Thanks, Roberto. Alright, so my portion is the southern portion of Eastgate. So just for a little refresher, the basic objectives was a new realignment of Stillhaven Road, a new parking lot for the baseball diamond, and along with that, it's going to be a new intersection with Stillhaven and Strombo with a pedestrian and bike path. So some pretty simple design criteria. I designed it with the WB50 vehicle. It's going to have 35-foot radiuses and a minimum 300-foot curb radius, as long as the standard 12-foot wide lanes, as you'll see here. So as you can see, you have the 35-foot radiuses. For turning, this is for the WB50, and you have the 12-foot wide 2-lane intersection. For the parking lot, I designed it for 113 spots, including 5 handicap spots here. So as you can see, top left, you have a handicap parking, and so your 5 spots. Each one is 10 by 20 foot, and they are 22-foot spaced. This is in accordance to the ordinance of Valparaiso, Indiana, for the city ordinances. I decided to do a curb and gutter. I know a lot of people did ditches, and with the limited amount of area, we decided that curb and gutter would be the best fit for the project. So with that, it was in design with the NDOT design manual. Decided to use type B with a 2% grade and 1.5% grade. As you can see here, this is my typical section for that. And then here I'll show you my bike and pedestrian path. I incorporated a little sightseeing loop with this, so there'll be some signage available for some vegetation and wildlife. As you can see here, it's a little turnaround region. That way no one will be standing in a standstill, blocking it off. It will also be 12-foot wide. This will allow emergency vehicles to get through just in case there's an emergency, and will allow easy access. My future work will be to create a detour route and to also refine my current work. Next up, for water resources, I am Gibbon.
So first off, I had an updated project overview. Highlighted in pink is going to be all the culverts that I will be designing for the site. The detention pond's going to be in red right there. All ditches will be highlighted in green, rain garden is purple, and my sand filter is going to be blue over on the right there. And then I split the site into an east side and west side, and I split them at Salt Creek right there, all the way on the right side of the screen. Okay, so for culvert 1, this is going to be located at the first drive-in for a parking lot. Went with a length of 70 feet, diameter of 3 feet. It's going to be corrugated steel, and the tailwater velocity coming out of the pipe is going to be 6.15 feet per second. This is with a design flow of, I believe, 36 cubic feet a second. And as you can see, the water won't go to the top of the road, so you shouldn't have a problem with flooding on the road. Culvert 2 is going to be the same sizing. I figured keep it consistent so that the contractor isn't going to be annoyed. This also had the same tailwater velocity and has the same flow, design flow. And this is going to be located at the other parking lot entrance. Culvert 3, this one's a little different because this is allowing the water to flow from Salt Creek under the road. It's going to have a length of 48 feet, so the span of the road, a diameter of 3 feet. Material is also going to be corrugated steel with the tailwater velocity of basically 5 feet per second. And as you can see, the water's not going to go onto the road, so that's always a good thing. All of these graphs were generated in HY8, if you wanted to know. And then I also had to do a detention pond. This is my cross section for my detention pond. It's at 6 foot depth, so it's a real deep detention pond. To mitigate for that, and put fencing around it so nobody falls in and hurts themselves in it. 3-to-1 slopes, and the bottom width is 248 feet. This is the top view of the detention pond. It's going to be 532 feet by 284 feet. I had to generate a hydrograph for the detention pond, inflow and outflow. For the outflow system, I used a pipe with a diameter of 2 feet. I haven't come up with a material for it yet, but the peak inflow for the detention pond should be 48 cubic feet a second. The peak outflow is going to be 7.32 cubic feet a second. And since my volume of the detention pond is 849,000 cubic feet and my flood control volume is 750,000 cubic feet, it should be able to hold the flood control volume. I also came up with a cross section for my ditch system. The ditches will have check dams within the ditch. I haven't come up with a length for the ditch yet, but this will be the cross section for all of them. I went with a depth of 2 feet, which is an overestimate because NDOT requires a freeboard of 1 foot for all their ditches along roads. I figured I'd also keep this consistent throughout the whole site so the contractor doesn't get angry. So it is a little over designed, but it's to make construction a little easier. Future work, I have to design my sand filters, my rain garden. I have to draw everything in CAD, and then I'll have to do a construction cost estimate once I get dimensioning for those other things. With that, is there any questions?
Okay, so as for the transportation people, so what type of intersections do we have? Do we have like traffic lights, roundabouts, or?
I went with 2 signalized intersections.
Okay, so let's look at Sterling Road over here. Do you have enough capacity between here and US 30 to put a signalized light? Storage capacity for cars.
Yeah, we said 30, this one?
So this is Sterling, yes.
Yeah.
And so what's the distance between this intersection and US 30?
Couldn't tell you off the top of my head.
So maybe ask the question differently. Do you have enough capacity? So when the light is red, how many cars can you store in that section?
I believe we should. The only time it would genuinely be red is probably either during passing periods. The main point of this was to have the right lane be a turn-only right lane. I'm speaking of Chapel Drive. Eastbound, west, eastbound. exiting out of Chapel Drive, the point was to have the right lane be a right lane turn only, right turn only lane, and have inductive loops in the middle lane as to only, I guess, stop the flow of traffic as seemed necessary. It would be the same on the westbound, on the northern westbound lane of the new connection.
So the question, is it a good choice to have a signalized intersection in this location? Because I know the first team also had the same choice. Which is in the back of my head, I say that's maybe not, do you have traffic
I
counts?
see your concerns, and yeah, during the initial design phase, I went through and I chose between a four-way stop. I did a couple, I went with four-way, two-way stop. I went with a signalized and I tried a roundabout. And in the end, at least during my experiences, this is with my changes. This was the intersection that best suited. It gave me a level of service A during my calculation.
Have no choice but to believe you.
Well, I believe I still have the numbers. So,
Well, you mentioned that the minimum pavement width is 36 feet, but you showed 4 lanes.
yeah, so I suppose it depends. I know it could be classified as a local, which the minimum pavement width is much lower. But I classified it as a collector because of how much traffic flow there was on these two, in Sturdy and Sohavy. So as for a collector road, the minimum pavement width is 36. And I decided to go with 2 lanes in each direction for the sole purpose of the 2 driveways on this road. It would just make, I guess, traffic flow smoother down this road if I wasn't clogging up with, you know.
Ryan, one quick question. You mentioned the culvert's diameter is 3 feet with, like, I believe you mentioned 36 CFS going through.
Yes.
Can you show me the watershed area for that 36 CFS?
I can. Let's see. I used, probably just be easier to go up. I used this whole area up to the creek all the way down over here. I used a pretty big area. I used a big area because I wasn't told where a lot of things were going until very late last semester. So I figured I might as well just do the whole area so that.
For
when-
that first culvert?
Yes, because I didn't know where everything was going.
How is your topography? Oh, well, you have a topo map, don't you?
I do.
So why you want to consider the entire watershed for one culvert?
I guess that's a pretty good point. I could probably go back and fix that. That's a good point.
So, like, with culverts again, so, yeah, could you tell us what those lines represent? The red and green and blue and,
This blue is the water, this blue is the water, and that blue is the water. I'm not exactly sure what the red and green are, but I know that since the water isn't completely filling the pipe, that's a good thing.
Energy guideline.
The energy, okay.
Head water level, tail water level.
Okay.
Good.
and then for the detention pond, you had a depth of 6 feet, right? Does that include the freeboard, or where's the water surface?
That includes it.
So the water surface, the water is 5 feet deep? And then there's a foot of freeboard, or is?
I don't know how deep the water is. I'd have to look back at my spreadsheet, like off the top of my head, I'm not exactly sure, but
Yeah, but so
I have
I
it
guess,
somewhere in there.
so does the water get to be 6 feet deep?
No,
And then
it'd
there's-
be 6 feet.
Okay,
That'd be a lot of water.
so the water has to be 5 feet or less?
Yes.
Okay.
So, kind of continuing on with this, let's say, as a client, I'm kind of thinking about what that fence is gonna look like aesthetically, right, on the site, especially going like 248 or 280, 284 square feet. Are there other options besides having something where you didn't have to run a fence?
I mean, you could probably put a wall around it, but I feel like a fence might look a little better than a wall.
Well, I mean, is there an option to not have maybe the depth, something shallower?
I'd have to make it a lot wider, so it'd take up a lot more area if it wasn't. So I need it to be at least 750,000 cubic feet. So technically I could make it shallower, but that would increase how much more area it would take up of the land. So it would be a much wider pond. So I figured taking up less area, making it deeper and putting a fence around it might be a little bit better.
Right. And that's also using the same watershed too.
Yeah, the larger watershed.
And then the other question, also on your side, is earlier our presentation had the sand filter also.
Mhm.
We placed it closer like to the building,
Mhm.
like as an immediate maybe treatment. And you have it like, almost like as an end treatment. Is there
Mhm.
a benefit to having it at the end?
So I figured that the sand filters might be good here because there's not a lot of area here and the sand filter shouldn't be too big. So this ditch is just gonna treat the water here, it's gonna bring the water. And then all the flood coming off will just go directly in the creek. I just figured it'd be a good spot to have them. I don't know if there's an advantage or disadvantage of where you have them, but
Well, I mean, treating it right before it goes to the creek, so,
yeah.
thank you.
Just a follow-up on your detention pond cross-section. I think the city of Valparaiso requires a safety ledge.
Okay,
So it's a pretty wide ledge, I think it's like 6 feet horizontal, 1 foot, when it's 1 foot down, so if someone falls in, they're only in 1 foot of water,
okay,
they can stand up, so
okay.
I should incorporate that.
I'll look into that.
So you say it's a detention pond, correct? Where is the outlet structure?
Okay, so this is the detention pond right here. The outlet is gonna be pitched right here so that anything that comes out is gonna go into the creek.
Without measure the flow like an outlet structure in there?
It's going to be a 2-foot diameter pipe in that corner.
Well, you cannot do that.
Okay.
You have to have an outlet structure.
Okay. The outlet structure would be that pipe with a 2-foot diameter.
Well, what are you allowed to release? What flow rates?
I'm not sure off the top of my head, like I said, but my peak outflow is 7.32 cubic feet per second. I know that's less than what's the standard.
No, it's, until your valve is allowing you like 0.13
Okay.
CFS per acre.
Okay, I must have found a number somewhere else then.
So you need an outlet structure usually.
Okay.
May I ask a question?
Yeah.
Can you go back to the map, the one
Mhm.
that you have?
Yeah.
Now, of course, I am not an engineer, so
Mhm.
forgive me for this, but I have a question about the parking lot for the senior living center.
Yeah, of course.
So the senior living center is 2 stories, right?
Correct.
So I'm just wondering, is there going to be parking on the other side of that lot too? It doesn't, I believe you said it has 2 handicap spots.
Yeah.
And I know that some people who live in senior living centers drive, and then families come and visit. So I was just wondering if we need more parking, or maybe that's just standard, that's just normal.
So the reason I designed it this way, and fair question, I also thought the same thing. I was looking at the trip generation manual, and according to, I believe it was the cubic footage or square footage of the building, they give you a standard number required for how many parking lots you would need. And after my calculations, I believe I overcalculated by 2 to 3 extra parking spots. I think it was like 2 parking spots I overcalculated for, or I overdesigned for. That's, I guess, the easiest way to put it is, I went off of the manual that I was given.
The building also is, the framing plan is designed to, it has 12 different units, there's 6 on each floor, so it's relatively, not that many people that are actually gonna be living there. It's more like actual like community space and other things like that, so.
Thank you.
Okay, thanks.